This is the United States, an active player in global maritime trade. Just look, container ships can be seen off both the East Coast and the West Coast. Now let's check how many of the largest container ships are operating near the U.S. coastline. Well, not a single one. And honestly, that's pretty strange, because ultra-large container ships can carry up to 24,000 TEU, that is 20-foot containers. That kind of scale is incredibly efficient for ocean trade. You might think these giants are rare worldwide, but they're not. They regularly sail between Asia and Europe, and in significant numbers. More than 70 of these megaships are constantly moving cargo from one hub to another. So it starts to look like the U.S. is ignoring the most efficient vessels out there. But that's not the real reason. The truth is, ultra-large container ships simply can't call at U.S. ports. And even if they did, they'd either arrive empty or run into dangerous conditions near almost every major port in the country. Today, we'll see why the U.S. is effectively closed to the most efficient cargo ships, and most importantly, why the country isn't doing much about it. First, let's figure out why the U.S. would even want these giant container ships when smaller vessels can already call at American ports just fine. They cruise along the coast for years, dock, unload, everything seems to work just fine. But that's only if you ignore the brutal math of shipping. Here's the thing. One ultra-large container vessel can haul about 24,000 containers in a single trip. A typical container ship carries roughly 6,000 to 7,000 containers. So to move the same amount of cargo, you need 3 and sometimes 4 mid-sized ships. You feel that difference immediately. The crew size on a ULCV and on a mid-sized ship is almost the same, which means 3 mid-sized ships require 3 crews, 3 payrolls, and 3 sets of operating costs. Money doesn't leak out slowly, it pours out. But that's not even the worst part. But the biggest expense at sea is fuel, and ships burn a lot of it. To give you a sense of scale, mid-sized container ships can consume about 50 to 200 US tons of fuel per day. Of course, a mega ship won't burn less, it'll consume from 200 to 400 tons per day. So is the giant ship worse? Nope, quite the opposite. The math favors the monsters. When you calculate fuel use per container, a mid-sized ship can end up burning roughly twice as much fuel per container as a ULCV. So the giants win there too. And yet, despite all that, these megaships still don't really operate in the US. And here's why. Take a look at MSC Tessa, one of the largest container ships on the planet. A true floating skyscraper. It seems like an enormous advantage, but there's a price. When you load that much steel and cargo onto a single hull, physics takes over. The ship sinks very deep into the water. Fully loaded mega container ships can have a draft of roughly 56 feet. To put that in perspective, it's like a 5-story building completely underwater. And that creates a major problem. When many U.S. ports were built, nobody was planning for super ships like these. Look here. These are the ports of New York and Jersey City, and they sit at the mouth of the Hudson River, where depths reach only around 49 feet. An ultra-large container ship comes in and runs aground. Philadelphia has the same issue. To reach the port, ships have to travel inland via the Delaware River, where the depth is also insufficient. And there are many ports across the U.S. like this. In fact, getting to some of them is difficult not just for the biggest container ships, but even for smaller vessels. Now jump to March 2022 in the Chesapeake Bay. The container ship Ever Forward is transiting the bay, not an ultra-giant, but still a very large ship. The route is routine, nothing exotic. The ship's draft is 43 feet, and the shipping channel is deeper than 49 feet. Sounds like there should be no problem, but not so fast. At one point, the ship drifts just slightly outside the channel, and that's enough. There isn't enough water under the keel. The hull settles onto the bottom, and the vessel gets stuck hard in the Chesapeake Bay. And then the real challenge begins. You have to get it out somehow. Ever Forward sat aground for more than a month. Refloating it required tugboats, localized dredging, and unloading hundreds of containers to reduce draft. And all that right in one of the most heavily trafficked maritime regions in the country. It may seem like it was just a mistake. So what does shallow port access have to do with it? If ships like this can run aground from one small wrong turn, imagine what happens with ultra-large container ships. And here's the most interesting part. Fixing this is extremely hard. To start, the U.S. would have to rework huge stretches of the approaches to its major ports. And although dredging can help, there's one serious obstacle: money. You need a lot of it. For example, in Virginia, dredging projects to deepen a shipping canal so it can handle ultra-large container ships have been underway since 2019. The work is estimated at a staggering $450 million. And that's an estimate, not the final cost, which usually ends up even higher. And even if you can find the money, dredging itself can be complicated by a simple fact: existing infrastructure can get in the way. Look, this is New York Harbor. Beneath the shipping channels leading into the port, there are dozens of underwater lifelines, communications cables, gas lines, water mains, and other networks the city simply can't function without. The problem is their exact locations can't always be verified quickly and accurately, so any work that disturbs the seabed isn't just about machines and sediment. It's always shadowed by the same question: what exactly is down there right now? In short, a deeper draft means bigger headaches. But ultra-large container ships come with another bonus: they're insanely tall. Fully loaded, their height above the water can reach about 189 feet. Without cargo, about 210 feet. But wait, if the seabed's the obstacle below, then nothing should be in the way above, right? And this is where the bridges come in. Bridges the U.S. built with the mindset of, we made it this tall, what on earth could not fit under it? Turns out something cannot. Ultra-large container ships. And honestly, you can't really blame the engineers. Who in the last century was seriously designing for monsters like that? But the reality is the U.S. now has a massive problem. In the country's biggest ports, bridges have basically become a ceiling. Their vertical clearance is typically around 150 to 180 feet, which means they can't accommodate an ultra-large container ship, whether it's fully loaded or completely empty. So there's only one real option: upgrade the bridges. In theory, that sounds straightforward. In practice, it's hell, both for budgets and for city logistics. Look, this is the Bayonne Bridge between New York and New Jersey. It was built back in 1931, and at the time, its 151-foot clearance felt more than sufficient. But by the 2010s, the ports ran into a problem. The new generation of huge container ships simply couldn't pass under the bridge. The answer was modernization. Work continued from 2013 to 2019. The clearance was increased to 217 feet, and the cost was, brace yourself, $1.7 billion. The financial hit was great, but the transportation impact was outright enormous. During construction, traffic had to be rerouted onto other roads, so New York spent several years being an even bigger traffic jam than usual. And here's the key point: raising a bridge's clearance isn't the only thing you need if you want to handle ultra-large container ships. A very recent incident made that painfully clear. In 2024, Baltimore saw one of the biggest infrastructure disasters in modern U.S. history. A container ship caused the collapse of a major span of the Francis Scott Key Bridge. You've probably heard the story. At first, the main suspect was the electronics. Failure on board meant the ship, MV Dolly, lost control and slammed into a bridge support. But investigations later suggested the bridge wasn't built to survive an impact like that. Same reason as before. It was designed long ago, and nobody was planning for ships of this scale. Yes, the bridge could handle everything it was engineered for: storm winds, the weight of the structure, vehicle traffic, even routine impacts from smaller vessels. But a collision with a mega container ship is a completely different level of energy, and older standards simply didn't account for that scenario. The bridge was missing something it needed to cope. Inspections found the piers didn't have protective buffers or barrier structures to absorb the force of a strike, and the span itself wasn't designed for a direct hit. So to let ultra-large container ships reach U.S. ports, the country would have to rebuild and retrofit a huge amount of infrastructure, and even then it might not be enough, because in the U.S., giant ships don't get along with nature. Look, the U.S. does a huge amount of seaborne trade with Asia. Often the route is pretty straightforward: the West Coast, the North Pacific, Asia. Medium-sized container ships handle it just fine, running back and forth every day, moving thousands of boxes. But with ultra-large container ships, it's not that simple. Their sheer size stops being an advantage and becomes a serious weakness. Take the MSC Arena, for example. It's about 1,300 feet long. That's nearly 4 American football fields end to end. And for an ultra-large container ship, that length is totally normal. After all, you need space to carry over 20,000 containers. But once a ship like that enters the northern Pacific, it can run into something nasty: parametric rolling. And this isn't the kind of a little rocking and it's over motion. Picture this. The waves are moving in the same direction as the ship, and their spacing is roughly comparable to the ship's length. At some point, the vessel locks into the sea's rhythm. One wave, tilt. The next, more tilt. And instead of a steady passage, the rolling ramps up fast and can spiral out of control. The truly dangerous part is that, at a certain point, the hull can start swinging so violently that the ship can heel up to 40 degrees from side to side. If you think container ships don't suffer from rolling the way old wooden ships did, think again. It's just a different kind of vulnerability. Now let's jump to 2020. The container ship 1 Apis hit parametric rolling in the North Pacific. The ship itself wasn't hit, but the economic damage was brutal. 1,816 containers went overboard, and there was an even bigger danger hidden in that. Among the containers that fell were 64 carrying hazardous cargo, including fireworks, batteries, and liquid ethanol. So yeah, the Pacific Ocean seems like it really doesn't want giant container ships heading for the U.S. West Coast. But there's still the East Coast, and it's not any easier there. In theory, big container ships don't need to cross the most dangerous waters. They just have to get through the Panama Canal, which, as it turns out, is the real impassable barrier. When the canal was first built, it was designed for very specific ships. The maximum length was about 965 feet, the maximum beam 106 feet, and the maximum draft roughly 39 feet. Anything even slightly outside those limits simply wasn't allowed in. That standard later got its own name, Panamax. If you fit, great. If you didn't, you had to find another route. To give you a sense of scale, today those dimensions roughly match container ships carrying 4,000 to 5,000 TEU, maybe 6,000 TEU at best. Even by early 2000 standards, that wasn't mega, it was a solid mid-sized ship. And back then, ultra-large container vessels would have looked like something out of science fiction. Here's the interesting part. Despite those limits, the Panama Canal is still one of the most important arteries of global trade. The reason is modernization. In 2016, Panama built a new set of locks, Neo-Panamax. The canal became wider, deeper, and more capable. But even now, it's still an impassable barrier for ultra-large container ships. After the upgrade, the canal can handle ships up to about 1,201 feet long, 168 feet wide, with a maximum draft of around 50 feet. In maritime logistics terms, that's a lot. Big ships can pass without trouble. But for ultra-large container vessels, those numbers don't change much. They still don't fit. With lengths around 1,312 feet and beams close to 197 feet, they're simply too big for the Panama Canal, even after the expansion. You might want to suggest widening the canal again, but Panama would say no. Because Panama understands something crucial. Expanding again doesn't guarantee success. The canal has a limitation you can't fix with concrete or excavators, and that limitation is rain. Yeah, that sounds weird. Let me explain. The entire canal runs on fresh water from Gatun Lake. Every time a ship enters the locks and is raised or lowered, the system releases lake water. One transit requires roughly 53 million gallons. That water flows through the locks and is then lost to the ocean. Everything depends on regular rainfall to refill the lake. But when Panama hits dry season, the water supply drops fast. And as the lake level falls, the canal's depth falls with it. So yes, the Panama Canal is still off limits to the very biggest container ships. And if that's the case, what should the U.S. do? Focus on upgrading its own ports. The United States is one of the key players in global trade. It has advanced ports and the infrastructure is built to handle millions of tons of cargo every year. But there's still one crucial thing missing. Picture a massive container ship pulling into port. So how do you unload it? The answer seems obvious: cranes. But that's exactly where many American ports run into serious trouble. To handle mega container ships, you need specialized ship-to-shore cranes. Huge, powerful machines with long booms designed specifically for those giants. And here's a curious statistic. In 2024, there were around 1,170 STS cranes worldwide. Only 184 of them were in the U.S. That's just 15%. In other words, very few. For comparison, Asia had roughly 780 of these cranes, which is about 52% of the world's fleet. And it's not like you can just go out and buy a few. We're talking about staggering money. A single STS crane costs at least $8 to $12 million. For specialized models, the price can easily rise to $14 to $20 million per unit. At that point, you're not buying equipment, you're making a major capital investment, especially if a terminal needs several cranes at once to service one giant ship in a single call. And the costs don't stop there. The port has to prep the berth, reinforce the supports, run the electrical infrastructure, train the crew, and integrate the new machines into existing logistics. In short, it takes a lot of money. And soon, it may take even more because of U.S.-China tensions, tariffs, restrictions, and all the rest. You might wonder what any of that has to do with cranes. Here's where it gets really interesting. Nearly 80% of the cranes currently operating in U.S. ports are made by Chinese companies. Not because anyone wanted it that way, but because the U.S. has almost no domestic production of this kind of equipment. And if ports want to buy new cranes, they'll still end up buying from China. There are essentially no real alternatives. Unsurprisingly, the U.S. isn't thrilled about that. The U.S. administration is now discussing imposing extremely high tariffs on Chinese port cranes, up to an additional 100% import duty. Now imagine trying to plan a port upgrade when a crane that was supposed to cost $15 million suddenly costs $30 million. At that point, the enthusiasm for accommodating ultra-large container ships tends to disappear. And you can see this across many states. They're in no rush to modernize their equipment. The exception is Virginia, which has gone all in on upgrades. In addition to active dredging, the state's also improving port infrastructure, meaning those same advanced cranes. The Norfolk terminal already has 29 modern units capable of handling up to 4 ultra-large vessels at the same time. The plan's to increase the number of cranes to 33 by 2027. Virginia is one of the few states clearly preparing to welcome the biggest ships on the water. And here's the crucial point people often miss. Even if a port has the right crane sitting on the docks, that doesn't guarantee it can actually operate smoothly, because a port isn't just berths and equipment by the water. It's a massive logistics machine that has to keep freight moving nonstop from the ship and onward, by rail, by truck, into distribution hubs. It's easy to assume the U.S. wouldn't struggle with this. So much cargo flows through American ports all the time. But there are issues. Just think back to the ports of Los Angeles and Long Beach in late 2021. At one point, 70 to 80 ships were anchored in San Pedro Bay, waiting for a berth. There were no storms, no accidents, no crane breakdowns. Everything looked calm. The problem was on land. COVID-19 was still reshaping consumer behavior, and Americans shifted hard into online shopping. Electronics, furniture, home appliances, things people used to buy in local stores started coming across the ocean instead. E-commerce surged by nearly a third, and container loads from Asia began arriving in waves, slamming the ports with sudden peak demand. The cranes could actually handle the influx. The real choke point was somewhere else entirely. The rail network that was supposed to pull containers out of the terminals and move them inland was so overloaded that cargo often sat 9 days or more before it could even get on a train. Highways didn't save the day either because trucking was close to a breakdown too. There weren't enough drivers. Gates and yard traffic slowed down, and trucks idled for hours trying to pick up containers. As a result, even unloaded containers didn't clear space on the terminals, and new ones piled up on top of the old ones. It's scary to imagine what happens if the U.S. starts receiving large numbers of mega container ships, but it's not hard to guess. Another gridlock event. That's exactly why, if the U.S. wants to reliably handle the biggest container vessels, both inbound and outbound, it has to upgrade the landside infrastructure as well. And it needs to happen fast, because while all this is going on, China isn't just building cranes, it's building container ships that are even larger and more efficient. Just when it feels like ships can't possibly get any bigger, something like this shows up. In Shanghai, a new concept ship called Green Sea Lion was recently unveiled, a giant container vessel designed to carry 27,500 TEU, about 3,000 more containers than the largest ships currently in service. And this isn't just a slick render for a presentation. The project has received preliminary approval, meaning the design is cleared an early review stage, and in principle, the ship can actually be built. But even the Chinese teams hit a snag at the design phase. Ultra-large container ships may be more fuel efficient per container than smaller vessels, yet in absolute terms, they still burn an enormous amount of fuel every day. Push capacity even higher, and the total appetite grows too. So the question becomes, how do you deal with that? Their answer is a dual-fuel propulsion system that can run on liquefied natural gas. That immediately puts the ship closer to the tightening environmental standards being rolled out by the International Maritime Organization. In other words, the idea is a ship that's bigger, more economical, and cleaner than anything currently crossing the oceans. And China isn't stopping there. Alongside this flagship concept, engineers proposed an entire lineup of large green vessels, 16,000 to 20,000 TEU classes using alternative fuels, including ammonia, plus concepts with redesigned hull forms to improve hydrodynamics and cut fuel consumption. So this isn't about one record breaker, it's a whole new generation of container ships. In this situation, the United States has little choice but to modernize and expand its ports. Sooner or later, it'll have to learn how to handle ships that are likely to become common all over the world.